This video is sponsored by Unify Academy Salem.
Dear students, I am Aravindh, Associate Professor. Today we are going to discuss about the subject Finite Element Analysis. So how to clear the Finite Element Analysis, how we have to easily pass the Finite Element Analysis. Just we have to go through some overview about these 5 units. So here we are having 5 units. The first unit is Introduction, and second unit is one-dimensional problem, and third unit is two-dimensional scalar variable problems. Fourth unit is two-dimensional vector variable problems, and fifth unit is isoparametric problems. So here you have to concentrate unit 3, 4 and 5. These 3 units are very important. Here similar third unit and fourth unit having the similar same formula. So you have to easily concentrate these 2 units and easily you have to pass for these 3 units. The next unit 1. So unit 1 is Introduction. So here the part B we are having 2 topics. One is weighted residual method, another one is Ritz techniques. So in this weighted residual methods we are having 4 subdivisions. One is point collocation method, another one is subdomain collocation method, least square method and Galerkin's method. So here we are having the simple, very simplest formulas are for the 4 formulas I written here. First you have to take R equals, the R is known as, that is residuals. Residuals means errors. So R is equal to 0, the first formula for point collocation method. And second one, subdomain collocation method. Here we have to take, that is integral of R dx is equal to 0. So here we have to find out the value of A values we have to find. After find out the A value, just we have to substitute in this differential equation. Next, integral of R dx. So here also we have to find out the unknown value of A. So next, in this least square method, first we have to take out the residuals, that is I is equal to integral of R square dx. After that, after find out the value of I, so we have to differentiate the I value with respect to A, that is you have to take is equal to 0 and find the value of A here. And next, there is Galerkin method. So here the y value is given in this problem and R value residual. So we have to multiply the y value and R value. After that we have to differentiate with respect to x and find out the value of A. It is very simple. These 4 topics are very simple. Just you have to concentrate. That is Galerkin method. Okay. So next, Ritz techniques. In this Ritz techniques we are having 2 series. One is polynomial series, another one is trigonometric series. So here in this polynomial series we are having, that is the formula y is equal to a1 plus a2 plus a3 x square into y. And next trigonometric series y is equal to a sin pi x by y. So here the 2 series you have to follow, any one series is enough. Either you have to follow polynomial series, otherwise you have to follow the trigonometric series. The most here polynomial series very easy when compared to trigonometric series, because y means here either sine, cos values are there, so you have feel some difficult. So you have to follow, that is y is equal to this simplest formula. Here you have to find out the value of A values. So here first, here another one formula is there in the Ritz techniques, that is potential energy. Potential energy formula, that is pi is equal to U minus W. Before starting the problem, you have to write the potential energy equation, that is pi is equal to U minus W. That is U is in the sense, that is strain energy, that is U is equal to EI divided by 2 integral of 0 to L d square y by dx square the whole square into dx. So next, work done. So work done W is equal to integral of 0 to L Wy dx plus Py max. So how we have to select the formula for y work done value means, so here in this Ritz techniques only 2 problems is there. The first problem belongs to, that is simply supported beam acting point load. So if simply supported beam is acting in point loads, you have to take work done W is equal to Py max. So you have to take Py max and find out the value of work done. Next, another, that is simply supported beam with UDL, uniformly distributed load. So here the work done formula is changed into integral of 0 to L Wy dx. So here we have to find out the value of W. So these 2 problems definitely in this Ritz techniques, these 2 problems only, either simply supported beam acting as the center point load and simply supported beam with UDL. So concentrate these 2 problems. These 2 problems is enough. So maybe here it is 11th A question and this is 11th B. Definitely 16th question is must be in Ritz technique only. You have to concentrate the Ritz techniques. 16th A questions also it is possible. So you never skip. You have to read these 2 questions is enough. Next, part A. So in this part here we are having 6 questions. So in the 6 questions, the most repeated questions is principle of maximum potential energy and weak formulation. So here the principle of maximum potential energy in the sense there is no problem, just you have to write out the formula pi is equal to u minus w. That's already you are studied in Ritz technique itself. So you have to write pi is equal to u minus w. It's enough to get 2 marks. Next, shape function. So shape function in the sense, no, don't read more. Shape functions is simply you have to say it is a shape of the element. It's called the shape function. And after that, difference between Ritz techniques and Galerkin method. So here in this problem, while we are solving the problem, we are easily find what is the difference between Ritz techniques and Galerkin technique. So easily we have to read these 2 questions. Next, various method to solving the boundary values problems. The same. While you are reading the problems, the same answer for the methods for solving boundary value problems. Next, weak formulation. And sixth question, various weighted residual methods. Already we have discussed the same methods here. So we have to concentrate these 6 questions. Definitely you will get 2 questions. And in the first unit, there is having a chance to ask the theory questions also. Only 2 theory questions is there. One is historical background of FEA and second one is general steps of FEA. So here the most important question is general steps of FEA. It is possible to ask in 11th B and as well as in 16th questions also, 16 part C also. So you never skip general steps of FEA. It is only simplest one, 110 step is there. It's very easy. So you have to concentrate these 2 questions and most important is general steps of FEA. Next we are moving for unit 2. So unit 2 is one-dimensional problems. So here that is unit 2 is a very vast unit. The many vast syllabus are there. More topics. The first topic is bar element, second topic is stresses, third one is vibration and heat transfers. So here in this bar element the subdivisions are there. 3 bar elements are there. One is one-dimensional taper bar, and here the same one-dimensional bar element we have to find out what is the temperature effects of the bar element. That is also we have to discuss. And next trusses and vibration modes. When compared to this, vibration is somewhat difficult. So just you have to skip the vibration problems. If you need, it is somewhat difficult when compared to all those things. So just you have to skip the vibration problems and you have to concentrate on trusses, because the trusses problem will also asked in the part C also, 16th questions. Either it may be 16A or B, definitely the trusses problem will be asked. And next we have to move for that is heat transfer. Here that is heat transfer is subdivided into 2 types. So one is composite wall problems, another one is fin element. The composite wall is definitely 12B question should be in heat transfer only. So bar element is 12A. Here the 12A is in bar element and 12B should be in composite wall. And you have to expect trusses questions, the same truss question from part C also. So you never skip unit 2. It's a vast syllabus. Anyway, the bar element problems are very easy when compared to these stresses and vibration. So here there is one-dimensional bar element and this is taper bar. So the only one formula for the entire unit you have to follow, that is general force equation. That is force F is equal to K into U. That is K in the sense that is stiffness matrix, that is U is displacement. So here in this bar element problem we have to find out the displacements U1, U2 and U3 values. So this is a simple example for the bar element. So the one and rounded value, this is element 1 and this is element 2. This is 1, 2, 3. This is denotes, this is nodal points. So in this nodal point, this is U1, U2 and U3. So here we have to find out what is the displacements values. With the help of this equation, we have to find out the displacement for element 1. We have to take separately element 1 and separately element 2, and we have to find out the stiffness matrix for element 1 and element 2. We have to substitute here, assemble the stiffness matrix, and we have to substitute here and find out the value of U1, U2 and U3. If always U1 value is 0, because which here it is fixed 1, so displacement is arrested, so U1 is 0, so we have to find U2 and U3 values. So there is nothing difference for general force equation for bar elements and temperature composite heat transfer problems. That is F is equal to K into T. So here F is equal to K into U, the same formula. So here in the stiffness matrix equation, here Young's modulus E and here thermal conductivity K value. Just the same formula, just we have to replace E in terms of K, that is thermal conductivity, and just here displacement, that is replaced in terms of temperature. So here we will find U1, U2 and U3 value, and here we have to find T1, T2 and T3 value. For trusses, I written the same formula, general force equation, F is equal to K into U. The stiffness matrix K value, that is AE divided by LE. Then the formula is not difficult, it is very simple. that is L square LM M square. Just we have to put minus for all those things. Just we have to write here, and the same thing for here also, the same formula. Just find out the value of K and substitute here and find the value of the displacement in the trusses elements. So you have to concentrate bar element, trusses and heat transfer. 12A, 12B, and here this is 16th question, part C. And here part A we are having 6 questions. The most repeated questions is first question, that is constitutive law. Second question is properties of stiffness matrix. And this fourth one is global, local and natural coordinates. In this question they can ask the difference. What is the difference between global, local and natural coordinates? So these 6 questions, definitely 2 questions we will attend. The next we are moving for unit 3. So unit is nothing but that is 2-dimensional scalar variable problems. Here part B. So part B we are having only Cst element. You have to concentrate only Cst element. So in this Cst element, the first question may be asked for a derivation for shape function and derive the strain displacement matrix. That is derivation for shape function you have to derive n1, n2, n3, and strain displacement matrix B matrix. How these 2 formulas came? With the help of this derivation we have to find out the shape function and displacement matrix B. So the first question having a chance determine the shape functions. So with the help of x and y, these 2 equations, so they given x1, y1, x2, y2, x3, y3 values in the problem itself. With the help of that we have to find out what is the 2 equations, x, y having v2 equation. Just we have to cancel and we have to find out the value of n1, n2 values, and here the same n1 plus n2 plus n3 equal to 1. So we find with the help of these 2 equations n1 and n2 value, just to substitute another unknown value n3 value we have to easily find with the help of this equation. So next strain displacement matrix B matrix, that is B matrix is equal to 1 by 2A q1 0 q2 0 q3, the same this formula. So how we have to find q1 q2 q3 with the help of this equation. So x1 y1 x2 y2 x3 y3 all the values are given in the problem. Just you have to substitute here. You have to find the value of q1, q2, q3, r1, r2, r3. Just substitute in this equation and find the area value. So area values, the formula for A is equal to 1 by 2, 1 x1 y1, 1 x2 y2, 1 x3 y3. So here we have to determine the value for area and substitute here. Just to keep it as it is, just you have to substitute, find one rounded value and keep it as it is. What is the value you get? You have to keep as it is in the matrix equation. You have to stop up to this. And next, mostly they can ask to find out the stiffness matrix. So stiffness matrix K is equal to B transpose dB into AT. So B formula, the same B formula, just we have to substitute here. And D, plane stress, in the D formula determine plane stress condition and plane strain condition is there. So you have to concentrate only plane stress condition, it is enough. So most rare cases only they will ask plane strain condition. You have to concentrate plane stress condition. D is equal to E by 1 minus gamma square 1 gamma 0. So here in this question paper they will given mu value. So just you have to, if they given mu means don't confuse. Just you have to replace in this formula, that is E divided by 1 minus mu square 1 mu 0 mu 1 0 0 0 1 minus mu divided by 2. So this is the formula. If they given mu means just you have to replace gamma in terms of mu. Just you have to substitute, find the value of D, and area is the same value, thickness value that is also given in the problem. Just substitute and find the K value. Just made on matrix form, that's all. No need to find for all. Enter, just you have to multiply all those things and find, and at last you have to find the value of K. So another, there is a chance to ask element stress and element strain. So element stress formula D sigma is equal to B into BU. So same D formula, B formula, and U1, U2, U3 values that is given in the problem. Just substitute, find here sigma 1, sigma 2 and sigma 3 value. So if they ask element strain, it is very simple. Just you have to find only the B value and you have to easily find E1, E2 and E3 strain values. You have to easily find. What are you are discussed in the third unit? The same formula, stiffness matrix same formula, element stress same formula, element strain same formula. The same formula obtained to the fourth unit also. So only the B formula is changed in the fourth unit, remaining as usual, plane stress condition, plane strain condition, D value, B, D value, the K, stiffness matrix K, sigma and Young small E values all are same formulas for the fourth unit also. This is 13A. It is more than enough. Only these formulas you have to by got it, it is more than enough. Next, another one chance is there heat transfer, that is 13B. So here they given one domain. Just we have to intersect the domain into element 1 and element 2. So here also, that is K value we have to find with the help of this relation So x1 y1, x2 y2, x3 y3, again here this is x3 y3. So first you have to take one element. For this element x1 y1, x2 y2, x3 y3. So here 1 2 3. The next point is here 1 3 4. For this element 2, this is x1 y1, this is x2 y2, and this is x3 y3. For this you have to separately you have to find for element 1, for element 2, this is element 1 and this is element 2. For these two you have to find out the value of k and substitute. B1 means the same formula what you have to for Cst element, the same formula for B1 also, B1, B2, B3, that is equal to Q1, Q2, Q3, the same formula. C1, C2, C3 is equal to R1, R2, R3, the same formula you have to take it here. Next part A. So here the part A we are having 6 questions. In the 6 questions, these 3 questions are very important. The first question is CST, LST and QST element. Just note down the definition for CST, LST and QST element. And next very important question, definitely this question in there in the question paper, plane stress and plane strain element. Just they can ask the difference or the definition for these two elements. And next governing equation for the heat transfer rule. Just write down the formulas for the governing equation. And next the 6th question, it is asked the properties of global stiffness matrix. In the unit 2 they can ask properties of stiffness matrix, but in the unit 3 they can ask properties of global stiffness matrix. So in this 3 questions, definitely this 6 question you have to attend 2 mark question and concentrate CST element, it is more than enough. Next we move for unit 4. So unit 4 is 2-dimensional vector variable problems. There is same what we have discussed in unit 3, the same for unit 4 also. Here in unit 3 we are having first half is CST element and second half is heat transfer problem. But in unit 4 there is nothing, only one option is there, that is axis symmetric problem. 14A is axis symmetric, 14B is also axis symmetric. There is no option for the depth question they want to ask. First question, if they possible to ask the derivation part for the axis symmetric problem. The same what we discussed in the CST element to derive shape function and strain displacement matrix. The same here also we have to derive shape function and strain displacement matrix for the axis symmetric problem. So here mostly they can ask stiffness matrix. Stiffness matrix formula, that is K is equal to 2 pi RA B transpose DB. The same, just you have to find B and D value, B value, just we have to substitute all and find out the value of K. So here in this CST element they can mention x1 y1, x2 y2, x3 y3 in the triangular element, but in the axis symmetric problem they are replaced x1 in terms of r1, y1 in terms of z1. Just we have to replace xy in terms of r and z. Here the B formula, that is B formula is equal to 1 by 2a, beta 1 0, beta 2 0, 0 beta 3, alpha 1 by r plus beta 1 plus gamma 1 z divided by r. So we have to find r with the help of this relation r1, r2, r3. r1, r2, r3 value is given. And z we have to find z1, z2, z3. Just we have to substitute and separately you have to write these formulas and find out that values and substitute in this formula. And we have to easily get B value. And here alpha 1, alpha 2, alpha 3. This is the formula for alpha 1, alpha 2, beta 1, beta 2, beta 3 value, gamma 1, gamma 2, gamma 3 value. So you have to by got only alpha 1, alpha 2, alpha 3. The same formulas for beta and gamma values. So these are all and all betas, these are and all gammas. See here 2, 3. Just Z2 minus Z3. So 3, 1, Z3 minus Z1. 1, 2, Z1 minus Z2. Same for gamma also. Here 3 is 2. So R3 minus R2. 1, 3, R1 minus R3. Z2, R2, Z1, R2 minus R1. The same. Just you have to by got alpha 1, alpha 2, alpha 3 value. The same you have to write for beta and gamma values. So you have to concentrate only axis symmetric. Definitely 14A and 14B should be axis symmetric. Just this formula, stiffness matrix formula and B formula, you have to by got it. Definitely you get 13 marks in the part B. And next part A. In this part A, the most important question is they can ask what is meant by axis symmetric element and consistive law for axis symmetric element. Just you have to treat these two question is very important repeated question. And basic steps for elastic equation, stress strain is D matrix formula. So you have to use D formula for here. I will written separately here. They can ask write the stress strain displacement matrix for the axis symmetric element. So you have to use D formula. This. So here also if they given mu, just we have to replace gamma in terms of mu. Next, difference between 2D scalar and vector. So 2D scalar in the sense it is without considering force, 2D vector means with considering force. That is the difference between these two. So condition for solve problem for axis symmetric, the same, what are the procedures we are followed, the same we have to write it here, we will get 2 marks. So next we are moving for unit 5. So unit 5 is isoparametric formulation. The same unit 4 is only for axis symmetric element, and next unit 5 is isoparametric formulation. So here you have to concentrate, that is Jacobian matrix. Jacobian matrix is very important. Definitely one question from the Jacobian matrix. So here if maybe the question should be asked like evaluate the Cartesian coordinates and evaluate the local coordinates. Don't confuse. If in the question they can ask if they evaluate Cartesian coordinates means you have to determine x and y values. If they ask evaluate local coordinate in the sense you have to find the epsilon and eta value. Don't confuse for these two values. Some of them if they don't understand what is local coordinate, they made a mistake, they can determine only xy value. So Cartesian means xy and local coordinates means epsilon and eta. Very simple formula. X is equal to n1 x1, n2 x2, n3 x3, n4 x4. So y, just we have to replace y1, y2, y3 and y4. Just replace x1 in terms of y1, y2, y3 and y4. This is simple formula. With the help of these formulas, you have to find out the value of Cartesian coordinates x and y. And n1 value, you have to find 1 by 4 is common for all. And 1 minus epsilon, 1 minus epsilon, 1 minus eta. Just you have to remember minus, minus, plus, minus, plus, plus, minus, minus. Just you have to remember like this. 1 by 4 is common for all the safe function n1, n2, n3, n4. So just you have to remember minus, minus, plus, minus, plus, plus, minus, plus. Just you have to remember like this and put epsilon eta, epsilon eta, epsilon eta for all the values. So easily you have to keep in mind n1, n2, n3, n4 for values. So with the help of this, you have to find out the values of epsilon and eta values. And next Jacobian matrix. So Jacobian matrix simple formula J11, J12, J21, J22. Don't get fear. The J11, J12, J21, J22 formula is like this. It's very simple. The same as it is. You have to keep it in. Remember minus, minus, plus, plus. Just you have to put x1, x2, x3, x4. The same formula for J12 also. 1 by 4 is common. Just you have to replace x1 in terms of y1. x1, y1. Just y2, y3, y4. The same formula just to replace x1 in terms of y. And next J21. The same. If they replace eta into epsilon, x1, x2, x3. The same formula you have to write for J22 also. Just you have to replace x in terms of y. y1, y2, y3 and y4. Just you have to find all the values and substitute here. That's all. This is Jacobian matrix. Easily we have to obtain the value of Jacobian. Definitely 15 mark question should be a Jacobian matrix only. And another one, next option, that is numerical integration. So numerical integration nothing but it's very easiest topic in 5th unit. So only one formula, I is equal to w1 f of x1, w2 f of x2, w3 f of x3. If they given 4, just we have to extend this formula. So here in the book they given one tabulation, 1 point Cartesian coordinate, 2 point Cartesian coordinate, 3 point Cartesian coordinate. Up to 3 point you have to keep it in remember. If the question paper it's not given, you have to by God 1 point, 2 point and 3 point Cartesian coordinate. Take that value based upon the question asked and you have to substitute in this formula. You have to obtain the value of I value. And here this is part A. So part A, here we are having 6 questions. The most important question is isoparametric, higher order, subparametric, superparametric and isoparametric elements. So the 4th question is asked in the big question also. They can ask what is explained, subparametric, superparametric and isoparametric element. In the big mark question also, part B also they can chance to ask. So you have to, don't forget to by God this subparametric, superparametric and isoparametric elements. Just read the difference between these 3. And isoparametric means it is 4-noded rectangular element. 1, 2, 3, 4. For CST, unit 3 and 4 are based upon triangular elements. So it is 3-noded triangular elements. CST element and axis symmetric elements are triangular element. That is 3-noded. 1, 2, 3. It's a triangular element. For isoparametric element, it is 4-noded rectangular element. 4 nodes are there. 1, 2, 3, 4. And you have to keep it sub, super and isoparametric element. And safe function for 4-noded element means the same. 4-noded safe function element formula is here. Just you have to write the formula here. And application of numerical integration. Next to Jacobian matrix. you have to write the formula for the Jacobian matrix. Okay, so don't forget Cartesian coordinates means xy, local coordinates means epsilon and eta, and Jacobian matrix formula. Just what I am saying, just you have to keep it remember like this, the formulas. It is very easy to obtain 13 marks. Already we have discussed it deeply, the unit 1, 2, 3, 4 and 5. 5 units we have to discuss it deeply. Now just we are moving for some overview. If you feel more difficult, you have to concentrate what are the topics we have to concentrate in the unit vises we have to discuss. The first unit you have to concentrate Ritz techniques. In the Ritz techniques, we are having simply supported beam in point load, simply supported beam for UDL. So these questions may be asked in the 16 part C also, 16A it may be asked. So you have to concentrate Ritz techniques for 11th question and as well as for part C also. And the second bar element. So in this bar element we are having more subdivision, that is unit 2 having more subdivision. We see already that is bar element, stresses, vibration, heat transfer problems, more vast syllabus in unit 2. So here you have to concentrate bar element. So bar element we have to definitely get one question in 12A. So we have to concentrate taper bar. Taper bar the same for one dimensional bar element also, temperature effects also. So don't skip bar element, entirely you have to see bar element. And they can ask part C stresses and vibration. So you feel vibration is very difficult, just you have to neglect, concentrate stress elements. So stresses same U1, U2, U3 for bar element also, for stresses also U1, U2, U3. Don't skip unit 2, you have to read it. Okay, next Cst element. For unit 3 Cst element. So in Cst element second half is also there, that's heat transfer. So here in the Cst element you have to find that is stiffness matrix K and its derivation. It's very simple, only you have to keep it remember the formulas. If you get past unit 3, 4, 5, concentrate these 3 units, definitely you will clear. The same formula for axis symmetric element also. In 14th axis symmetric element there is no option. So you have to read K value and they ask element stress and element strain value and derivation also. Don't skip units. It's very simplest unit is unit 4. Just keep remember the formulas. And unit for isoparametric elements. In the isoparametric element concentrate Jacobian matrix. Definitely you will obtain Jacobian matrix formulas. Okay. Thank you. If you have any doubt of this finite element analysis, you have to please put it on the comment and subscribe. Thank you.